Hello everyone, welcome back to my YouTube channel. First of all, subscribe my channel and press the bell icon for more updated videos. I have uploaded a lot of videos for you, but I am receiving a lot of comments related to heat load calculation of clean rooms and hospitals. So today we will discuss how to calculate the heat load for clean rooms and hospitals. So I'm using this one of my project that I am working on it, uh, that is the ground floor of pharmaceutical company, that is the new injectable facility. In this you can see there are a lot of spaces, that is vial washing area, sterilization room. These UNC are untreated or uncontrolled rooms where ISO are not applied. These are simple air conditioned rooms, and these rooms are pressurized rooms. In this you can see this is sterilization room, which is ISO 7. How we know that it is ISO 7? So it depends upon its particle size. We just do some testing, DOP testing, to calculate the particle size. Then we just suggest that this is the ISO 7. So for ISO 7 we have different number of air changes, that is air changes per hour. For ISO 5 to 6 we have 150 to 400 or 60 to 100. For ISO 6 it is 60 to 100. These are different spaces we have in this drawing: powder filling room 1, offloading area, tools exit, material exit. These are different ISO classes from ISO 5 to ISO 8. So for ISO 8 there are different ACH that we have selected for our project. From here we will start from powder filling room 1, that is in the zone 1 on ground floor. Powder filling room 1. So this is the powder filling room 1, which is the ISO 5 and ISO 6. In this you can see the arrow is just pointed toward the tool exit. It means that the powder filling room is pressurized as compared to tools exit and offloading area. And also ISO 6, because we do not want any contaminant to flow toward this area, that is powder filling room. So these rooms are at different pressure differential. You can see the arrows show the flow of airflow toward the different areas. So we will start from powder filling room. I have already calculated this in zone 1. Here you can see the powder filling room 1. So we will start from here. In background we have just selected the weather data for Pakistan, Islamabad, that is the latitude, longitude, elevation. This is not included in HAB. I have just manually put all the data in these design parameters. So second one is the space, that is the powder filling room 1. For this you have to just name it and then calculate the floor area. What is the floor area? Floor area is basically the 19.10, that is 19 feet and 10 inches by 16 inches, so which is the around about 320 square feet. And for outdoor ventilation requirement, just like the miscellaneous pharmacy preparation area, which is the 5 CFM per person. For internals we have already calculated the load for these spaces. Like we are using 24 watt light, that is the number of lights are 12, so 12 multiplied by 24, which is around about 288 watts of light load. and there is no other load. And for electrical equipment, you can use electrical equipment load here in watts. If you have any load like ampule filling machine and other filling machines, so you can put it here, just put the number of people here. And for the schedule, you can just select the hourly profile. Hourly profile is basically the running condition of air condition. So the air condition is running 24 hours, so I just select the all of them on to 100%. Like if your company is running from 9 to 5, so you can just put it down, make it 0%, and from 9 to 5 make it 100%, and just click OK. So I'm using 100% for all time because the air condition, these are the air conditioned spaces which will be working 24 hours. And second thing is select the wall. In my case, I have just consider this wall is exposed because the material exit area wall is also exposed. So I have just consider one wall is exposed to the outside. In some cases, and worst case scenario, if this material exit is not air conditioned, so this wall will be exposed. If in your case, if there is no wall exposed, so you just don't select any wall for exposure. So in second thing, if it's first floor and there is a roof, you can select roof. But in this case, this is ground floor, there is a conditioned space above this, so just select not used. For infiltration, I am using 0.35 ACH for infiltration. For floor above the floor above this ground floor is conditioned space, so I just select this one. If it's first floor, then select floor above unconditioned space and put the outside temperature. And I select the wall partition. These walls are the wall partition, and the temperature against these walls are same. Here and here temperature are same, so these both are conditioned spaces. So just click on it and press OK. After adding these all the data of the spaces, then go for a system. In system, you have to do first, that is zone component. Select all spaces and add it in this zone component. I just give it a name, zone 1, ISO 6. These all are ISO 6 rooms, ISO 6 spaces. In thermostat schedule, you can just select the thermostat set point. In my case, it's 22 plus minus 2, which is roundabout in Fahrenheit, that is 71.6. So for thermostat schedule, I am using 100% because the load will be 100% 24 hours. It's working for 24 hours, so I just select the profile that is on 100% occupied from 24 hours, from 0 to 24. So just press OK. And the main part of this calculation is supply terminals. For supply terminals, all zones, these are ISO 6 zone. So we are using for ISO 6, that is 6200 ACH. For this, you have just put and just select the ACH and put 60 here. This is the main part of the design. It's same for hospital and same for pharmacies and also for other clean rooms. So just press it OK. If you have any zone heating unit, you can consider this, but in my case there is no zone heating unit. And after this, you will just select the ventilation size method, that is ASHRAE 62.1 2010. And if there is any damper leak rate, you can just put it here. If there is no, your you are sure that your damper have no leak rate, so just put it 0. And second thing is more important in clean rooms and hospital, that is dehumidification. In this case we are using 35% of relative humidity. 35, we need to maintain 35% relative humidity. So you are just put this dehumidification and put the value which you want to maintain in your area. In, like you can see, it is 35, 60, different for different classes. You can watch my video for clean rooms, in which I have defined different ACH for different classes of clean rooms for ISO and different other international standards. In this central cooling, you just select the cooling source. In my case, this is the chilled water. I am using the chilled water for cooling. If you are using the condensing unit, you can just select from here. You can just select equipment type here. If you are using a split air handling unit, that is the you can say condensing unit, but in my case I'm using a chilled water air handling unit, so I just click this one. And these are the main parts of clean rooms and hospital calculation. Just press it OK. After this, click on the load. I can show you the load, that is 36.5 ton. Remember this, in pharmacy the load is very high because of the high ACH rates. So this is small area, but the load is, you can see, is 36.5 tons. It calculates the flow rate for AHU, that is the 87.72 water flow rate, and coil load, coil CFM, and entering, that is the off coil and on coil temperature, dry bulb and well blood, that is 73.2, 45.8. The air will enter, the water will enter at some temperature and leave the other side at some different temperatures. The air will enter at some temperature, and with outlet temperature will be different. And you can see there is the CFM per person, that is 15.68 CFM per person total for building. And the load is calculated for separate spaces. So I have just mentioned the powder filling. So the powder filling is 6.3 MBH mega BTU per hour in June of and this time. So airflow is 3364 CFM, which is high, you can see, because of the high ACH rate. And these are the different parameters. You can check the file window area and its load and planium load, and different type of loads are defined here. And this is central cooling coil, outlet temperature, inlet temperature, supply fan outlet, and zone air, return plenum. These are defined. You can just take these data and make a equipment schedule, and you can select your equipment from here. It's a very useful software for the calculation. Here this is the psychometric chart for the calculation in is show the specific humidity at different temperatures. Thank you for watching my video. If you have any comments, you can ask me anytime, and keep watching my video and comment on different videos, and keep sharing, please. I am doing this for you all people. Thank you.